one vector, but so based their representation. So the second limitation is their representation uh, solely on the distributional statistic obtained from corpora, ignoring the waves of information provided by existing semantic resource. So based on these questions, don't, uh, we cannot um, like represent the different sense of the bank, like the meaning of financial institution and the um, like land beside the river. Um, both of things are projected into the same vector. So we have to propose another method that can project different sense of word. Uh, we can project the representation of different sense into different uh, vectors. So in contrast to word embedding, which obtain a single model for potentially ambiguous words, sense embedding are continuous representation of individual word sense. So to be able to apply word embedding technique to obtain representation for individual word sense, um, a large sense annotated cobra have to be available. However, manually sense annotation data set is hard to obtain, and it is time consuming process. 好，这边是想要跟大家讲，就是大家还记得我们这个介绍 word embedding 的时候，基本上一个字它就是对应了一个向量，不管它是几维，就是100维1到1000维，总之它就是只能投射到向量空间得到一个向量这样。那这个就有个问题是我们一直提到说，比如说 bank 好了，bank 我目前知道就是一直谈的是它有银行的意思或是河岸的意思。好，那这样的话就会有个问题，我们可能会取决于我们训练这个 word embedding 的 corpus，导致说它的 sense 或许是偏向某一边的。什么意思呢？就是假设说我们今天拿的比较偏财务的文章来训练 word embedding 的话，那或许大家看到这边的这个向量呢，它会更接近于其他财务相关的词汇啊。然后那如果我想要把它用来表示河岸的话，那就意义就不太一样嘛。就是大家还记得我们之前谈到说word embedding 它应该会有某种特性是说它的 context 相同的情况下，应该会那些字可能会更容易群聚在一起。所以今天这个如果我们是拿财务领域的文章来 train word embedding，那这个 bank 呢，它就可能跟那些财务相关的词汇群聚在一起，而不是跟河岸。所以在这个情况下，就是有一些人就提出了这个 sense embedding 的这个方法，来让每一个word 就是它有不同的 sense 的情况下，我们可以把它投射到不同的向量这样子。那我们就一个向量表示它这个对应的 sense。所以我们今天就可以指定说它是第一个 sense 的bank 第一个 sense 的情况下，我得到了一个向量，第二个 sense 我得到另外一个向量，然后第三个 sense 我得到第三个向量。好，那这边同学可能又会稍微疑惑一点说，那他们都是 bank 我要怎么分说它是什么样的 sense？那基本上这边呢，它就会有一个 tag，比如说假设我这边写这个下标1、下标2、下标3， 基本上它就是我们透过不同的 tag 来知道说今天它是代表哪个 sense 这样。OK。Okay, so I have mentioned some sense annotated corpora, and we know that the sense annotated corpora are important for training sense embeddings. So here are some sense annotated corpora like WordNet. We already know that the core unit in WordNet is the synset, and a synset represents a concept or a meaning which is represented by its various sense. For example, the synset defined as motor vehicle with four wheels can be expressed by its synonymous sense like auto, automobile, auto machine, and motor car. So we can use the WordNet to train the like sense embeddings, or we can use for the task of word sense disambiguation. And the second sense annotated corpora is semicolon. Um, it was manually annotated and consistent of 350 two documents from the Brown corpus, and it contains many sense annotation. So it is the largest manually annotated corpus and the most well-known and widely used in the literature to train word sense disambiguation model, especially supervised learning model. And the third resource is the corpus released from SAM-EVIL. SAM-EVIL is a well-known uh, workshop in natural language processing. So if you want to search some dataset, you can search the dataset released from the shared text in SAM-EVIL. So the SAM-EVIL dataset provide reliable benchmark for testing word sense disambiguation models. So you can see that um, there are a serious shared text in SAM-EVIL are related to the task of word sense disambiguation, and it contains around 7,000 sense annotation. So we can also use this resource to train our word sense disambiguation model. Okay, so here I introduced three well-known resources for the task of word sense disambiguation. 好，这边就是有提到说有几个常用到的 corpus，像是前面我们讲到，WordNet 当然可以用来用来当做我们的这个人工标记的资料。所谓人工标记的资料是什么呢？我再跟大家介绍一下，就是比如说这个例子，它可能就会有标说 bank 是什么意思，这样bank 是什么 sense，就是所谓有人工标记的资料。那 WordNet 当然就是它的范例会有嘛，我看一下，像是这边它就会提到什么这个 bank 什么什么 bank 怎样，那这个就代表说这个字是属于这个 sense，那就是当然就是你的一个人工标注的资料 ，OK，然后再来就是也有人就是在1993年的时候呢，他们就用了一个非常庞大的资料集去请人标记每个 word 的 sense 是什么，这就叫做semicolon，然后再来是 SAM-EVIL，SAM-EVIL 是在在源处理领域里面呢是常常 就是每一年呢，它会有不同的 share task，像是办比赛这样，然后都是跟自然语言处理相关的这些比赛。那当然就是过去有几届就是有办跟 word sense distribution 相关的这个比赛。那当然办比赛嘛，他们就会 release data set，所以那我们就可以拿它的这个 data set 来做研究。OK，那所以这是三个这个跟 word sense distribution 相关的这个sense annotated 的 core part。Okay, so in addition to the three datasets from the previous slides, an alternative direction is to use Wikipedia as a source of sense label data. For example, when a concept is mentioned in a Wikipedia article, the article text may contain an explicitly link to the concept Wikipedia page, which is named as a unique identifier. And we can view the link as a sense annotation because the ambiguous words are linked to a different Wikipedia article depending on its meaning in the context. For example, the ambiguous word bar can be referred to the page bar law or the page bar music. And you can see that in this sentence, after graduating from law school in 1834, Sumner was admitted to the bar. So here, the word bar is linked to the page bar law. Okay, so based on the information of linked page on Wikipedia, we can use this information in the test of word sense disambiguation. 好，这边就是再跟大家介绍还有一个另外的方向，就是除了前一页提到的3个 data set，我们也可以去爬这个 Wikipedia 的资料来建立跟 word sense disambiguation 相关的任务。好，像这边有提到说，像是 bar 这个字，它其实也有很多个 sense，然后在 Wikipedia 上面被整理成它可能是用在跟 low 有关，或者是跟音乐有关。好，那如果说我们看到一个句子，那它有这个 link，它会在指到另外一个页面来解释这个意思，那你就可以看到说，哦，这个 bar 在这个句子里面，它是指的是说，它是跟这个这个法律相关的这个用法这样子。所以当然这样的资讯你也可以视为是有标注上这个word sense 的用法。OK。So let's see how to use the information from different kind of links. Okay, the first kind of link in uh, uh, sorry, the link. There are some kind of links provided by Wikipedia, like direct link. The direct link means the surface is the same with the identifier. For example, we can see uh, computation linguistics is linked to the page. It is also called computational linguistics. So you can see that the surface or the reference is the same. So the first type of link is direct link. And the second type of link is piped link. For example, uh, in this figure, uh, the sense. Okay. In this article, it only mentioned the word sense, and if you click the link, and it will return uh, the page called word sense. So a pipe link is an internal link that display text that is different from the title of the page to which the text link. Oh, okay. So there is another example, like if you uh, find there is a sentence also in the Wikipedia article, it's called the word station, and it would be linked to the Wikipedia article about train station. And the third types of link is called redirect pages. So here is a definition. Redirected is a page which automatically sends a visitor to another page, usually an article or section of an article. So the reason is that different contributor may use different names for the same entities. Like someone uh, write down the sentence with the word UK, or another contributors just write United Kingdom. Then uh, Wikipedia provide redirect page to link these words together, so we know that UK is referred to United Kingdom. So there's only one page which actually containing the description. Uh, like if we type UK in the search box or click the wiki link with UK, we will be taken to the article United Kingdom. And there's another useful pages provided by the Wikipedia. It is called disambiguation page. Like for ambiguous word, there are several pages describing different meaning of word. For example, Michael Jordan. We know Michael Jordan uh, is an American basketball player, or you can see that there are many uh, athletes also called Michael Jordan, like um, football player, or a hockey player, and uh, uh, some other Michael Jordan uh, is not are not athlete. They are they are actor or businessmen or researchers in machine learning and artificial intelligence. Okay, uh, so in the previous slide, we have introduced uh, three links and oh sorry, two links and two pages. 好，因为这边在说明说这个我们可以怎么利用 Wikipedia 来建立相关的资讯。那像是维基百科他们都会有这种连结，可以让我们知道说它的呃这个词，它可能不是只有一个字，它可能有几个词，字组成的词汇，指到是什么样的页面来介绍它这个意思。所以这样的资讯是非常好的，就是可以适用于就是我们知道说这个词在一个句子里面的用法是什么。那其中这个 direct link 就是说它的这个用词在这个 context 里面跟它 指向到的这个页面是用词是一样的，然后也有可能是它有不同的呈现方式，可能有不同的写法的话，然后它可能会也不应该不是说不同的写法，而是说像是sense，它是只有用到 sense，那如果是完整的这个表示的句子应该是不是句子词汇是 word sense，那它可能就会指到这个word sense 这样子，那是一个嗯不同的这个 display text 这样子。然后再来是因为每一个因为 Wikipedia 的句子是由使用者贡献的这样子，那每个人写的这个词可能会很不一样。那他们有整理出，他这些词应该是要对应到是某个意思，像刚刚提到这个 UK 是 United Kingdom 的缩写的一种写法，或是呃就是他可能会整理说，还有可能也许还有不同的写法，都是指到这个 United Kingdom，然后重点是这个他们就只会有United Kingdom 这种比较，就是他会同时都指到这个 United Kingdom，那只有 United Kingdom 它会有这个对于这个词的解释这样。然后接下来就是disambiguation page，就是像是我们知道有些词它我们已经知道有些词它是有不同意涵，那是最有名的例子就是 Michael Jordan 啊，我们知道他大部分我们提到他的时候可能会觉得说他是 basketball player，然后那其实但是 Michael Jordan 可能也是指别的人，像是他可能是别的不同种类的这个运动的选手，或是他可能从事不同的行业这样子。好，所以这个可能也是一种蛮有用的资讯，就是也许可以用来就是在整理过后变成这个可以用于这个任务的资料。OK， so based on the link information from Wikipedia, we can utilize this information to construct a dataset for word sense disambiguation. For example, we can see there are 3 sentences in this slide, and these sentences are about the ambiguous word bar. You can see bar refer to the meaning of law or music, okay, or establishment. So we can say these sentence express different meaning in different. Sorry, we can say the word bar in this sentence express different meaning in different contexts. And this sentence collected from Wikipedia can be added to the training data for training the supervised model. But note that we might be careful to some case that like we have to map the concept from Wikipedia to other resource like WordNet, because uh, there may be not an explicitly mapping rule from Wikipedia to WordNet. And so based on the previous slide, I think hyperlink can be regarded as annotation. And there are a resource called BubNet is already utilize the resource collect from Wikipedia, and it's mapped the information from Wikipedia to WordNet, and it is a large sense annotated resource. 好，所以这是总结一下，就是 当然我们可以从 Wikipedia 上面的这些句子来收集我们所谓的有 sense tag 的这种标记的训练资料集。然后那可能有一点要注意是，也许就是中间就是如果说我们要把这个 Wikipedia 跟 WordNet 做一些 mapping 的话，要注意就是这个呃怎么去做 mapping，因为它可能不一定有lexical overlap，就是重复的字。那其实实际上已经有人有建立这样的 resource，那它叫做 BubbleNet，后面我们会跟大家介绍 BubbleNet。那不过我们现在刚好到下课休息时间，那我们就先下课休息10分钟，等一下我们再来谈这个呃后续的跟 word sentence aggregation 相关的一些不管是资料集啊还是方法。好，那我们就先下课休息10分钟。 好，那我们再来上课吧。好，那接下来要跟大家介绍的是 BubbleNet。Okay, so we have mentioned that BubbleNet is an alternative, powerful resource for checking the sense of words. So next, I want to share a useful dictionary that providing a powerful API, and it's also provide the definition of uh, each sense of words. So according to the API, it provides the service of disambiguating word sense. So it is BubbleNet. And you can click the link to search the sense of word in different language, and you can also check out the API service provided by the website. So BubbleNet is a wide coverage multilingual semantic network obtained from the integration of various uh, sources and dictionary like WordNet with Wikipedia. So uh, being a superset of all these resources, BubbleNet brings together lexicographic and in uh, uh, and it can serve as a dictionary or a resource containing multiple uh, knowledge in the world. So it containing both named entities and concept, and moreover, unlike Wikipedia covering only noun instance, uh, the instance in BubbleNet um, have various part of speech text, including noun, verb, adjectives, and adverbs. So given its multilingual nature, uh, uh, I remember that BubbleNet covers over around uh, 250 languages. So BubbleNet has been used as a sense uh, inventory for annotating text in language other than English. 基本上就是BubbleNet 它是 multilingual 的，就是说它是有提供非常多种语言的sense sense 的资料，比如说当然这个什么bank 这个字当然是有这样英文，那我们可以去查这个 bank 它的这个 sense，像是在前页，就是大家可以去查，就是你比如说输入 bank，然后选英文，那它就会回传这个它的对应的页面。好，好，那不然我直接操作给大家看一下。好，我找一下哦。好，我们刚刚有提到，就是BubbleNet，它是多语言的，所以大家可以看，就是你可以选你现在要查的字的语言是什么，像大家看到这个英文啊、中文啊，还有很多日文、韩文等等的，西班牙文、葡萄牙文的都有。好，那比如说我们还是用英文的来试试看，那我们之前就是常用的是例子是 bank， 好，那就 enter 之后呢，就可以找到说，它记录了很多跟就是属于名词的时候的 bank 的资讯， 然后这底下是它的这个编号这样子。那后面我们会介绍说这个怎么使用。好，除了名词，看看底下有没有别的。OK，也有动词。OK，就是不同的sense 都有在记录在这上面。然后你可以看到是，嗯，基本上大家可以假设它是有照着这个 sense 常不常用的情况下来排序的，所以我们通常会假设说这个就是常用的 sense，这个也是常用的 sense，可能就是比较次要，再一直往下就是更次要的这个 sense。好，那这是BubbleNet 的网页。OK， so what is the process of constructing BubbleNet? BubbleNet combined word embeddings and sorry, not word embedding. It combines WordNet and Wikipedia by automatically acquiring a mapping between WordNet sense and Wikipedia. So you can see that, for example, there is a word play, then it can search the word play in the WordNet and the play in the Wikipedia, and they can they find the overlapping of the sense. Here are some overlapping, and here are some sense are only included in the WordNet, and there are some sense only included in Wikipedia. So they can integrate these two resources. And since they want to construct a multilingual resource, so there's an important process to mapping different language. So the process of constructing BubbleNet starts by harvesting human edit translation provided by Wikipedia with its inter language links. And in order to fill translation gaps, for example, there are some missing translation for a resource poor language. So they use a state-of-the-art statistical machine translation system to apply to millions of sense text sentence from Wikipedia and semicolon sentence. And they utilize the machine translation system and they get the synset in different languages. So as a result, a substantial part of existing WordNet is covered, and it also provides many normal lexicalization. 好，所以总结来说，就是BubbleNet 的这个作者，他合并的这两大 resource，然后可能有一些是没有被 cover 到的，那他们就是等于说结合之后，当然就有更丰富的资讯。然后那还有就是他想要做多语言的这种资料集，所以他就透过了翻译的机器的这个模型，然后就可以获得到在就是新设在不同语言的这个表示的这个词汇是什么这样子。好，OK，那这大概就是这个建立 BubbleNet 的一个概念，但中间当然有很多细节，比如说 怎么 mapping 什么，那这边就是留给大家自己有兴趣看 BubbleNet 的 paper。OK，好，那这页就是刚刚有秀给大家看的，就是你可以输入任意你想要查询的字，然后选这个语言，然后就可以得到这个它的sense。好 Okay, we also mentioned that BubbleNet provide service for the user to search the sense of the words in a given context. So the word sense disambiguation provided, the word sense disambiguation API provided by WordNet is called BubbleFeed. And here's an example. This is the a screenshot of the website, and you can text the sentence. Then and you can also choose the language. Then you click the button, then it will return the word sentence disambiguation result. And I prepare an example for you to see the function. So here is an example. I used to be a banker, but I lost interest. So here you can see that the word with green highlight, and it's there is a sense provided by the bubble fee, and you can see used, it means to perform a habit to leave. Okay, or banker is a financier who own or is an executive in a bank, or there is a meaning of lost. And the most interesting thing is the word interest. Okay, uh, in general, we know that interest means we have some, uh, we are, sorry, we can, uh, we pay attention on something. And, but here in this sentence, the interest means fixed charge for borrowing money. So you can see that the word sense disambiguation service provided by the bubble fee is really good, right? It's known that based on the concept, especially the word banker, uh, it's uh, disambiguate the sense of the word's interest is about the sense related to finance. OK，所以这边的例子是说，就是我们有个句子，输入到这个 Bubble Fee 这个服务中，就是前一页这个，大家可以试试看哦，把任何你想测试的句子放在这边，然后它就会帮你去disambiguate 每个 word 在这个句子中的 sense。像是我如果输入这一句，那如果大家开始接触这个想要开始做这个期末的 project 的时候，应该对这个句子会有点眼熟，不太确定，但这是一个很有趣的例子。好，那他是说就是说我曾经是一名银行家，但后面是什么呢？就是有多种解释嘛，就是根据这个interest 有常用的 sense，就是说表示说我们对某种东西是有特别的兴趣的这样子，然后就是我们可能特别关注这件事情这样子。好，那是兴趣的意思。那可是如果大家可以看到搭配这个 banker 在这个 context 里面，它其实是可以表达另外一个 sense 来让这个句子拥有了不同的含义。然后像是 interest，它有另外一个意思是利息。所以如果它是不同的 sense，如果是利息的话，它其实解读起来也蛮有趣的。他就是他失去了他的这个利息，他就不再是一名银行家这样子。好，那所以这边就是一个也可以算是一种双关语，很有意思的这个就是如果我们对这个字有不同的解读，那它可能可以表达出某种不同的意涵，甚至有包含一点幽默感这样子。好，所以我们可以利用这个bubble fee 来帮我们做 disambiguation，然后我们可以知道这个 word 在这个句子里面的 sense 是什么。OK， So in the following slide, I want to introduce the task about homographic punctuation location detection, or we can say identification. And this is important for punctuation understanding. Okay, so I will introduce this paper that it's proposed a novel framework for homographic punctuation location identification. So what is pun? Pun is a subtle rhetorical device which derives the humor by creating a surprise based on the ambiguity of uh, multiple interpretation of the words. 接下来我想要介绍这篇论文的方法，就是它是做也就是让大家做了期末的报告，就是跟双关语的这个侦测是相关的这样子。好，那所以胖就是双关语，那也就是我们前面提到的这个例子，interest 这边就是一个双关语的位置。OK。所以找出句子中的双关语的位置，就叫做这个homographic punctuation location identification. Okay. So we start from some example to understand there's the issues in the task of homographic punctuation location identification. Okay. Here are for example. The first sentence is I used to be a banker, but I lost interest. So the first sense is a sense of concern or curiosity. And the second sense, especially in this sentence, the sense in this sentence is a fixed charge for borrowing money. So the pound is the noun interest, which has these two meanings. And the second sentence is you can see it's a clumsy reflection of yourself when you break a mirror. So in this sentence, the pound reflection is actually in the same word meaning, but different interpretation can be made by these contexts. For example, reflection can be referred as reflecting a light or the personality. Okay. And the third sentence is when no nomadic tree sense danger it pick up its trunk and leaves. So the word leaves can be a noun, the plural of leaf, right? And it can be a verb, like the third person singular of leaf. 所以这边就是说它可能是名词动词。OK， 那so based on the different part of speech take, it represent different meaning. And the fourth sentence, if you say you have bad skin, I'd say that was a poor excuse. This is different from the previous example, like you can see the word poor. The word poor sounds similar to the other word poor, P-O-O-R. Okay, so this sentence is not belong to homographic pound. It is homophonic pound. Okay, so in this work, they ignored this kind of pound. Okay. 好，我们这边举的4个例子来说明这个，关于双关语的这个性质。然后这边有提，一开始的这个句子已经有介绍过，就是 双关语的词，它就是有可能会有多个 sense，所以造成它有双关的意思。然后再来就是这个reflection，它的意涵是有可能会是说它可以反射光线，也有可能是用在说反映我们的个人的性质的这种感觉。OK，在这个句子里面，然后再来是在这一句中，就是说这个字 leaves，它可以指的是动词的离开嘛，像这个句子看起来很像是他打包了，然后呃呃然后离开这样子。OK，那当然也可以说是 leaves，因为如果是有前面这些什么tree 啊什么的，那好像也是可以说是叶子的意思，这样子就是有双关的感觉。那但是在最后一个是它其实也是一种双关语，就是说呃这个 pore 是毛孔，然后但它念起来很像是poor，就是很差、很贫穷、不好的这种意思这样子。那所以在这边就是搭配的 best skin，那它用这个poor excuse，就是会变成说在这个发音上有这种双关的意涵。那又可以是是语音层面的，然后就跟所谓的 homographic 是不一样的，就是它并不是说是这个字有不同的意涵，而是它的发音是导致说可以带来不同的意涵这样子。OK， so the author have two observation on pounds. And the first observation is oh, sorry, this is a typo. Okay, the existence of a support term that hints a secondary meaning of the pound. So what is this meaning? And back to the previous slide. And for example, in the first sentence, we know the pound is interest. And there are two meanings, right? The first is a sense of concern or curiosity. The second meaning is a fixed charge for borrowing money. But actually, in this sentence, it's used the second meaning. But how do we know that? Okay, so the clue is the word banker. So in this case, we can call the word banker as a support term, right? So if we want to find out the pound, we can also to try to find the support term. Okay. And the second observation is the pound is likely to locate in the rear part of its context. So for example, in this third example, okay, you can find that the bold word means the pound in this sentence. And you can see that these pounds are appear like the last words. So these are the two observations of the author. 好，所以这意思就是说，就是我们在找双关语的时候，我们为什么会知道它是双关的词汇，是因为我们可以找到一个支持它的这个一个叫做 support term 的意思，就是说根据这个字，我知道说它不是用一个常用到的 sense 这样子。那还有另外一个 observation，就是说大家可以看说，哎，它这个出题字它大部分是出现在后面，它是 pound，然后出现在句子后半部，这也算蛮合理的嘛，就是我们前面会有带一些概念进来，比如说 banker 之类的。好，然后我们在后面提到了这个双关语的时候，大家才会会心一笑说，哦，这个用意在这边是这样子啊，这样子。OK。Okay, so for the support term, on the one hand, the context of a pound will suggest reader a common interpretation. And on the other hand, there exists a support term which has a strong uh, correlation with uh, the with another sense of the pound. So for example, back to the first sentence, the support term banker has a strong correlation of the second in this example is the second sense of the interest. Okay, so the support term gives the reader a hint about the second interpretation. So, oh, okay, here is the example. Banker is the support term for the pound interest. And we already know that the first meaning of interest is about a sense of concern or curiosity, and can be understood even if the word banker is replace another job title like engineer. So uh, uh, the second meaning of interest is uh, a fixed charge for borrowing money is unrevealed without the hint of banker, right? If we change the banker to engineer, then uh, the word interest is not no longer representing the meaning of uh, a fixed charge for borrowing money, right? So in other words, a pound cannot stand without the support term. So the support term is important for the task of pound location identification. 好，这边只是再补充说明一下，就是关于 support term 的重要性，就是说，如果今天同学们把这个 banker 换成另外一个字，比如说工程师，那这边这个 interest 就不再有表达双关的意味了。OK。So based on the author observation, the pound is more likely to appear in the rare part of its context, like the punchline in a joke. The pound will have more powerful effect. Um, so uh, like if there is a delicate elaboration beforehand. So like in the these three sentences, we can find that there are two sentences. Sorry, the pound stand in the second half part, like interest and lip, right? And so they calculate the position ratio of the pound in the data set uh, released by this author by dividing the pound location indexed by the length of a whole sentence. They found the mean position ratio is 0.73 with a standard deviation of 0.25. So this result supports the observation. 好，这边只是补充那个作者们有在计算的这个平均位置，就是说双关语是在哪个位置，那通常都是在偏后面的位置。OK，就是等于是偏向于在句子的一半的以后。OK， so based on the observation, they propose a number of frameworks. Their framework for pound location identification contains the following two stages. So the first stage is use probably to label the sense of every word in the sentence, or it's we can also call the sentence as instance. Okay, and so the first stage suggests the pound candidate given an instance, and the second stage is label a sense to the the word in the sentence. So the second stage select the most probable sense from the candidates to obtain the final result. 好，总之就是我们可以先用这个 bubble v 来 label sense，然后最后会有就是中间会有确定的一些过程，知道说我们要给它什么样的 sense，然后找出究竟谁才是双关语，然后就根据这样的方法可以做这个 pound location identification 的这个 task。Okay, so for the nomination of the pound candidates, the word sense disambiguation tool assign a common sense to the word based on the context of word. So the first case is if the tool assign a common sense to the word. And so um, if the word is a pound, okay, there exists another sense and a support term that has a high similarity between the the uh, the first sense and another sense. So they measure the similarity between each possible sense of words I and the sense of each word in the context, and then get another sense of word I. So if the word if the sense has the maximum similarity to the support word, the sense of another word uh, uh, in the context, sorry, it means that the word is the word has another sense. OK， 这边就是说，可能那个 word sense disambiguation 的 tool，它可能会assign 一个 concept，assign 一个 sense，那个 sense 可能算是common sense。那我们不能说它如果是 common sense 的话，就不一定就不是双关语嘛。那所以我们也是要去判断说它是不是双关语。那判断的方式就是说根据 observation， 就是去找 support term。那找support term 的话呢，就是说在句子中会有另外一个字，就是非第二个字，然后它可能会和目前给定的这个第二个字呢，会的另外一个 sense， 它会有一个蛮高的 similarity， 那我们就可以说它很有可能就是双关语这样子。So they suggest word I as a pound candidate if it has the highest similarity change defined as the follow, like use the function, the equation of sim change, and it means the score of this candidate. And here are two equations to measure the score of specific meaning and the score of the common meanings. So based on the change of the similarity, it can be represented as the possibility of the word is a pound. 好，这边意思就是再重复一次，就是它会基本上是iteratively 的去算这个cosine similarity。那首先要讲到的是就是如果我们今天有一个word 被 take 了 sense，然后我们想要知道它是不是双关语，然后就跟句子中的每个字可以去算这个 cosine similarity，然后 那基本上这个字它可能会有很多个 sense 嘛，对不对？像 bank 前面大家看到它有很多个 sense，那它就可以一一去算 cosine similarity。那再补充一下，我刚刚一直没有提到，我遗漏了这样子，就是所谓不同 sense 的 embedding 呢，就是当然就是前面一开始我介绍到有 sense embedding 这个东西，那基本上是有人有 train 好了这个 sense embedding，所以也许在大家的期末 project 可以用来试试看这样子。好，好，那就是说我们去算的这个 similarity，就是每个 word 跟它就是不同的 sense 算 cosine similarity，然后我们可以找出说，哎，这个 support term 跟这个 word I 的另外一个 sense 有高度的相关性，那我们就可以猜测它很有可能是双关语这样子。那总之就是，那要怎么去比较呃谁才是真正有可能是双关语呢？就是根据这个相似度的变化，因为我们可以说就是如果它是双关语的话，基本上它在这个句子中所使用到的 sense 跟原本的 sense 的差距是很大的。比如说我们一开始提到那个interest 原本是兴趣，那后来它变成是利息，或者是叶子跟离开这两个 sense 也是差距很大的，所以我们可以根据它的 sense 的偏移度来衡量这个被标成common meaning 的这个字是不是有可能是双关语的。OK， and in the second case, if the word sense disambiguation tool assign a specific sense to the word I, uh, uh, it is because the decision of the tool is affected by the support term in the context, right? So we expect that the decision will be changed if the support term is being replaced. So for the word I, they look up the support term and uh, and change the support term. Uh, uh, so uh, so how to find the support term? It's also used the uh, uh, used by measuring the cosine similarity, and they choose the word the support word, sorry, the word with the highest similarity as the support term. So then replace the word with an OOV words. Okay, then they can perform the word census ambiguation again to find the suggestion of uh, the tool. So if the newly labeled sense is different from the original sense, then the word I will be suggested as the pound candidate with these results. So if no pound candidate is found, or close more, the other words uh, uh, have different meaning. Okay, will be suggested as the pound candidate. Okay, so this is the process of uh, identifying the pound location. So for the experiments, they collect several sentences from the website, and actually they only use the traceable sentence. Uh, uh, for example, the phonological is not the case it being investigated in these papers. Uh, so as a result, they only use 100 instances. And here are some special case of pound like compound. For example, um, the instant of compound have multiple pounds or one pound in multiple word form, like got into a pickle 代表是陷入困境，可是 pickle 它其实是有泡菜意思，然后就是腌制菜那种意思，然后再来就是 cut the master 的就是它的意思是没有成功，没能成功这样，但是它这个字又是代表芥末的意思，所以大家可以看就是如果它是用多个字组成，又代表不同意思。好，但这个比较复杂，就是暂时没有在这个 work 所研究。然后the last example is suspicious that stand for the case in which the pound is hardly found, like the word hard and soft. It is joke, but only one interpretation and not a real pound. Okay. So they also try some method to select the pound, like choose the pound with the higher scores based on the previous process, and or they randomly select the candidate which locate have have part of the sentence, or uh, pick the last candidate in the instance. So here are some experimental results, and we can see that their method is better than other the baseline method. So uh, I think you can also try it in your final project. OK，好，那最后是跟大家介绍个 Bubble Fee 怎么用，然后希望对大家的做期末专题可以提供一点这个想法这样子。好，那前面有提到这个 Bubble Fee，它是一个 API，然后大家可以去 check 一下它的这个一些 guide，就是还有说它的那个function 怎么使用等等的。那大家记得，就是如果要使用这个服务的话，要先注册，然后所以就注册之后，他会给你一个 key，那你就可以我记得它限制一天是有几次的这个使用的次数这样子。那总之就是，如果要使用的话，可以来看一下这个 Bubble Fee。OK。好，那接下来就是有些范例，像是如何去 disambiguate sentence。那首先就是当然就是注册完就会得到 key，那你就可以把你得到的 key 放在这个位置，然后再来就是很简单，我们就先建立一个 string，然后这边是我们刚刚看到的例子 interest 那个例子，然后我们可以用Python 的这个request 来得到这个传给他这个句子，然后你可以设定你的语言是什么，然后跟你的 key 之后，它就可以回传它这个 word sentence ambiguation 的 result。然后那回传回来是这个 JSON 的格式，那你可以看到是我刚刚有提到有一个很重要的是这个BubbleNet 它有提供那个它的 ID， 对不对？就是大家可以看那个每个 sense 底下有这个编号，所以那你可以做这个 mapping 来知道说这个它的这个 ID 是什么。然后这个还有一个重点就是它这个 ID 是 map 到它我们后面会看到的一个 sense embedding，所以你就可以再跟 sense embedding 做结合。好，总之就是大家可以根据这个 bubble synset ID 来得到这个对应的这个sense embedding，甚至可以跟wordnet 来做 mapping。OK， 好，那剩下的资讯就可能只是说它是哪一个 token，可以根据这个起始的 index 跟看一下，是这个吗？哦，token 应该是这个，它是第几个 index 的字这样子，2、3、4、5、6、7、8，1、2、3、4、5、6、7、8、9、10。OK，所以它是这样算的。好，那总之就是我可以根据这个index 来找说它是对于哪一个字的这个资讯。OK，然后再来就是我们要怎么取得它的sense，可以去呃 比如说得到这个 word 的 sense，然后我们可以知道说它应该怎么对到wordnet，就是可以用这个get sense 这个function。那对，然后这边只是说我们是拿到这个 interest 的这个结果，然后我们就可以再把这个 word 呢传到这个呃呃跟这个 API 要这个资料是 get 这个 interest 的所有的 sense，然后大家可以看它就会传回来这个interest 的 sense，然后其中有一个是wordnet offset，就是可以 map 到 wordnet，所以大家可以用这个 ID 去 map 到 wordnet。好，那 map 到 wordnet 就是好处是什么呢？就是我们可以去看说它是不是一个 common 的 word sense。那当然也是可以根据这个BubbleNet 上面排的顺序来当做一个 hint 来看说它是不是一个 common sense。那这边就是说因为 WordNet 是有用那个 semicolon 去统计它的 sense frequency，所以当然我们也可以用它所提供的资讯来找说根据我们前面所得到的这个这个 sense 所对应的这个就在 BubbleNet 的这个 sense 对到这个 WordNet 的话，它是排第几名的？那这边就只是单纯说我可以去取得每个sense，大家就是每个 word 它的 sense 在这个WordNet 里面它的 frequency。那取得 frequency 这边就是左边是它的WordNet 的这些 synset ID。那我们前面找到的是13318584584 ，OK。所以大家可以看到它是排在这个位置133185584，OK。好，然后所以你就可以大概知道说它不是最常用的 sense。好，然后这是 interest 的例子嘛，那大家可以看到第一名最常用的 sense 就是这个就是兴趣的意思，OK。好，那很快来看到就是这个 sense embedding，就是我们前面有提到word embedding 它只能一个字对到一个 word vector 嘛。那如果说我们想知道 bank 在第一个 sense 对到某个 vector，bank 在第二个 sense 对到某个 vector 的话，那我们就需要用到 sense embedding。那我们不用自己 train，因为之前已经有人 train 过了，我们只要把它 download 下来就好了。那我之前是 download 这个sense embedding 第一个这个，那大家可以下载其他来看看这样。好，总之就是在这个情况下，我们就可以用到这个 sense embedding，那我们就可以根据 BubbleNet 所提供的那个 ID 来知道说对应这个 sense 它的 embedding 是什么。那我们下一页我有放一个例子，好，这是我下载下来的。在这个 interest 的部分呢，就是我们刚好看到，就是一开始我们再回去一下哈，OK，在这个例子里面，这 interest 被解释为是BN00047080N 这个 ID，然后这是网页上的资讯嘛，就是它是一个fixed charge for borrowing money，OK，so 这边那如果你是interest，然后后面底线接上它的 ID，你就可以找到它对应的这个vector。好，然后那接下来是当然说，如果你今天有别的 sense，那它是别的 ID，你也可以在底线后面换别的 sense，然后别的 ID，然后就可以得到它对应的这个 vector。好，那这边再跟大家说明一下，就是这个怎么去解读哈，就是它是一行一行的，然后每一行的前面的 index 零这个位置是这个 token，就如果你是 word embedding 的话，那第一个 index 在 sense embedding 就是说它有这个 token，然后底线跟它的这个它的 sense 的 ID，然后后面就是剩下就是它的对应的word vector。如果你是300维的话，那后面就会有300个数字这样子。OK，好，那希望可以给大家一些 no problem。那最后是列一些这个我们前面所提到的 sense tag corpora，那这是就是可以下载的资源了，但 我们这次作业可能就不能这样使用。那因为了排名，就是比赛排名要点这个公平性，用了大量的 training data，你可能当然就是会比较 performance 会比较好嘛。那所以在这次的作业可能就不适用。但是当然就是如果同学你是自己做相关的议题的话，就没有那么多限制了嘛。OK，所以这也是提供给大家参考哈。那我们就先下课休息10分钟，我们等一下再回来再讲后面的内容。那等一下我有准备的就是关于同学们有跟助教提的问题，然后我也稍微再跟大家说明一下这样子。好，好，那我们就先下课休息。 们再来上课吧。好，我有看到助教有回复大家的问题，然后助教也有跟我提到一些同学们在做作业的时候遇到的问题，那我这边也当做补充说明跟大家介绍一些这个像是比如说怎么解啊，或者是一些注意的事情。好，那大家最近可能在写作业3，那有同学可能就跟助教提问说，他的这个资料集用来 train 他的这个 N-gram language model 呢，会有蛮大的限制，就是比如说，也许是因为它的 training corpus 比较小，那有些字没有看过，那基本上根本就猜不中那个选项这样子。好，所以第一个问题是说，那这样要怎么办呢？要怎么去解决这个问题？首先当然就是可能我们要怎么去扩充我们的训练资料。好，那一开始助教在介绍这个作业的时候有在投影片上面有列说，可能可以再下载什么样的资源，像是我们之前找到的是那个 CNN 的Daily News，就是新闻文章。好，那个也可以试试看，因为我记得我们设计的题目里面有提到说，用不同的训练资料对于这个performance 的影响。OK，那呃如果是说有很多 OB 的这个情况，那我要怎么再扩充我的训练资料？那我之前在很久很久之前吧，我有介绍到我们可以下载这个 Wikipedia 的文章。好，那怎么下载呢？就是基本上我们可以下载这个 Wikipedia 的文章来当做我们的训练资料嘛。然后那问题就是怎么下载？OK，在介绍 language model 那时候的最后一页，我有放上，就是说，我们要怎么去下载 Wikipedia 的 data set，的 articles。那这边我帮大家找好，就是这个网址。那大家点进来应该就可以看到说，下面有好多种不同语言的 dump。好，然后像是当时应该是3月多的时候，所以这个是3月多的时候的 dump。那现在应该它一段时间就会有新的版本，所以大家可以去看看。那这个 开头的这个 wiki 就是英文文章的 dump，然后像是 zh 就是中文的 dump，所以根据你要做的这个语言，你可以去找对应这个语言的 dump，所以我们是英文的嘛，那基本上就是用这个 wiki。好，那但是如果你下载下来之后，我记得是 XML 的格式，那你当然可以自己写一个你的extractor 去截取出这个 article，就是你要的资讯这样。那另外我帮大家找了这个在 GitHub 上面有人有写好了这个Wiki Extractor，那它就可以帮你抽出纯文字的资讯。所以如果同学想试试看的话，也可以用他写好的工具来帮你截取出这个文件这个句子这样子。OK，所以那这个就提供给大家参考，好吗？就是大家可以试试看。好。那如果还是有问题的话，那当然就是比如说同学也可以另外再找data set。不过我觉得 Wikipedia 应该是还算蛮大的了。好，那但当然就是过程中同学们做作业遇到任何的问题，你都可以写进你的报告。OK，好，就当做一种讨论嘛，就是你的方法的分析跟讨论。OK，好，然后再来是。好，那这是作业3的这个回复。再来是 final project 的部分，就是助教有提到 no external corpus for final project。那这边的意思是说，如果是直接拿相似任务，比如说我们 final project 是要做 pond location identification，那如果是我 再拿也是做 pound location identification 的这个 task 的资料集的话，那当然就不太好这样子，因为这样就可能相对来说就不公平了嘛。好，然后那所谓的我们还可以用什么样的资源来帮我们做这个任务呢？像是你可能有用到什么 pre-trained model WordNet，然后像刚刚提到 sense embedding，bubble B 那些，都是可以使用的这样子，就当做额外的资讯来辅助你判断这个 pound 的位置。OK。好，那这是关于这个homework 3跟final project 的说明。OK。好，然后就我所知，最近就是助教有开始要准备第4个作业嘛。好，那可能就是会比我们一开始在课程的时候公告的这个时间稍微晚一点，但没有关系，我们都可以再往后延一点时间，让大家都有充分的时间准备。好，然后再接下来是想要跟大家介绍 clustering 跟 dimension reduction，然后这2个技术是可以跟我们前面所介绍的word embedding 来做结合的，就帮助我们去分析我们的 word vector。OK。Okay, so the last few weeks we have talked about the word embeddings, which is an algorithm that projects words into a vector space. So now I want to discuss some techniques that are related to the issues of analyzing word vectors. So these techniques are clustering and dimension reduction. So both clustering and dimension reduction belong to unsupervised learning. So for someone who may not understand unsupervised learning or and supervised learning, um, uh, let's say if if we have a data called x, okay, then we want to predict something. So like we want to predict positive, okay, sorry, or negative. So for example, X is an article. Uh, Text is kind of hard. Wait a second. Ah, okay. Is this a text or a tweet? And we want to identify whether the text is express the positive polarity or the negative. For example, the positive sentiment means I'm happy, or the negative means I'm sad. Okay, so if we want to classify the text, uh, if we have the data set with the input X and we have the uh, label like positive or negative, we can call we have a Y uh, called label. Okay, so in this case, it's called supervised learning. Okay, we have the input data and we have the label of output data. And if we don't have label data, then it means we have to use the unsupervised learning method to solve this problem. Okay, so here clustering and dimension reduction are unsupervised learning, which means we don't have a label of the cluster, or we don't know how many uh, uh, we don't know how to which is sorry, we don't know how to, what dimension should be is a better choice. Okay, for example, we have the word embedding like uh, uh, with 300 numbers in the vector, and I don't know is 3 or 4 or 5 or 50 is mm, uh, uh, is the better case to being reducted. Okay, so uh, in general, we use cluster uh, analysis and dimension reduction to solve different problems, and but they can be used together, in fact. So here are some motivation that I think it will help you to understand the concept of clustering and dimension reduction. Um, so first, we use clustering because we believe that there are some hidden category in our data, and we attempt to find out the hidden categories with properly defined like similarity or distance between each pair of data points. And we use dimension reduction because we believe that there's some redundancy in our original feature space, and we want to eliminate that. So the purpose is usually to reduce some unimportant uh, features in the vector. So um, to manually analyze or interpret the data on the transformed feature space, we are going to further feed the data into our model. The data means the feature vector, like there are some vector to represent each data, and we want to try if using the dimension reduce new features can improve the final performance. So the first motivation is to cluster the data into the several category. And here you can see that there are 3 category, but actually we don't know whether there are 3 classes or 4 classes. We just uh, uh, define there may be 3 classes in this data, or you can also define the class D. It can also be used for the clustering task. So to sum up, the motivation of clustering is to cluster the data set, the data into several class defined by yourself. And the second motivation, uh, the motivation of the um, dimension reduction is uh, to uh, reduce the space of the vector, like from a high dimension to lower dimension. So in this case, we hope that some redundancy feature will be filtered out, and based on the more important features, our model can achieve a better performance on this task. 好，这边就是跟大家说明一下，在使用这个 clustering 跟降维的这个2个动机。首先就是我们想要分群，我们可能觉得说，我们的这个资料里面它可能会有几群这样子，比如说假设我们在分文章的 domain 好了，我们可能有一大群文章这样子，然后它可能有属于科幻的小说，可能属于新闻，可能属于什么不对属于科学杂志等等的，有不同主题，然后我们可以用它的这个feature。那这个 feature 是可能是来自于word embedding，那可能有比如说有某种 document embedding 的方式，那根据这个 embedding 我们可以去分群，分出它可能有哪几类。那这个类别的数量是根据我们自己定的，你可以定 如果你知道有几种，那就是定那几种；如果你不知道，你可以猜说可能有哪几群，那这就是我们自己定的。那另外就是降维的部分，就是它关于降维其实有两个 motivation，一个是当然就是减少不重要的 feature，来让我的model 可能就是少一点 noise，那它可以达到更好 performance。那第二种motivation 是我想要去观察这个资料的分布。OK，那接下来就是跟大家介绍这两个方法。Okay, so for the clustering, we will introduce k-means clustering, and for dimension reduction, we will introduce principal component analysis, which is also called PCA. And but note that we will not go too deep in these two methods because I think it is not very related to our course, but I still want to introduce the concept. So you will understand why how to use these algorithm in your task. Okay, so for the clustering problem, we are given unlabeled data set, and we want to use an algorithm that can automatically group the data into coherent subset or coherent clusters for us. So the k-means algorithm is one of most widely used clustering algorithm. So in the following slide, I will introduce what the k-means algorithm is and how it works. So what is the situation of using k-means? Let's say if we want to take an unlabeled data, like these pictures shows some unlabeled data, and it's represent that this vector, uh, sorry, the vector like 2.1 and 0.1 represent the feature of these data points. Okay, so here are some unlabeled data, and we want to group these data into like two cluster. Okay, so if we want to perform the k-mean clustering algorithm, there are several steps we have to do. 好。这边就是说，这边是一堆 unlabeled data。那我们现在想要分群，假设我们想要分两群，那我们来看有哪些事情要做的。Okay, so our goal is to group our data into two clusters. So the first step is randomly initialize 2 points, and the 2 points are the cluster centroid. So these two crosses are called cluster centroids. And k-means is an algorithm that iteratively does the following two things. The first thing is cluster assignment step, and the second step is a move centroid step. So formally, the first step in the k-mean algorithm will go through each of example, and so it will go through all these black node, black dot in this figure, and depending on whether it's closer to the red cluster centroid or the blue cluster centroid, it is going to assign each of data points to one of the two cluster centroids. So the process is to go through our data and color each data point either red or blue. So um, the way to color each of a point is dependent on whether it's related to which cluster century. So this step is called a cluster assignment step. And the second part is in the k-means algorithm is the move century step. And we are going to do is to um, uh, take the two cluster century. Um, for example, here are two cluster century, are red cross and blue cross, and we are going to move them to the average of the points that are belongs to these clusters. So okay, so in the following slide, there is an example. So I want to use the example to introduce these two steps. So what we are going to do is look at uh, uh, all the red point and compute the average. So for example, in the first step, we randomly initialize the two classes century, and I, I have to we have to color the dot which based on the distance between the classes century. So if uh, this dot is close to the dot close to the red cross, then I will color it with red color. And for example, this dot is it's more closer uh, to the blue point than red. Sorry, the blue cross than the red cross. Then I will color it as the blue color. So you can see that in this picture, you can see that the dot close to the red cross are colored with red color, and the dot close to the blue cross are colored with the blue. So um, then we have to compute the average of these red dots and the blue dot. Then we have to move the cluster century to the average the mean of the location. So um, we can view the process as finding the mean of the location of all the red points and the blue points. And we are going to move the red cluster century to the mean of the location. So you can see the red cross is moved to this location, and the blue cross moved to here. Okay. And so we move the cluster centuries as follow, and now we uh, move them to the new mean. And then we go back to another cluster assignment step. So we again uh, going to look at all of our unlabeled example, and depending on whether it is closer to the red cross or the blue cross. So we again color them either red or blue, dependent on the distance. Okay, so we assign each point to one of the two cluster centroid, and then uh, we are going to do another second step, which is called move centroid step. So we compute the uh, average of all the blue points and the red points, and uh, sorry, we compute the uh, 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 compute the average of all the points, and move the cluster century to the mean of location. Then we get another location of the new cluster century. So we do one more cluster assignment. So now we have sorry now we have a new uh, cluster assignment result that these dots belong to the red course, and these dots related to sorry these dots are belonged to the blue cluster century. So then we perform the two step again. We obtain another result. So we keep so we keep iteratively uh, running several times of k-means algorithm until the cluster century do not change anymore and the color of the point will not change. It means that k-means has coverage and find the two cluster in the data set. 那这边就是很快跟大家讲一下这个概念，但这不是我们这门课很重要的点，但就是跟大家说明一下，就是它的过程，大家就可以更清楚知道说，我们的这个 clustering 在这个我们的这个议题上是可以怎么用的。总之就是，我们先随机选两个呃cluster 的代表的位置，然后开始我们会去 assign 这些点给这两个 cluster，然后我们又重新算一下平均，然后算一下点的平均移动这个 cluster century 到中心的位置，然后再重新计算一次，然后嗯之后哦不对，移动到那个位置之后，我们会有新的属于这个 cluster century 的点，然后我们再计算它的平均值，再移动点，然后呢再重新分配属于这个 cluster 的点，这样子，然后一直重复这个过程，直到说我们这个 cluster century 的位置不再变化了，那我们就等于说是找到了嗯可以分成这两个 cluster 的这个方式，也就是说我知道说属于第一个 cluster 是哪些资料，属于第二个 cluster 是属于哪些资料。那回到自然语言处理的议题好了，大家可以想象哦，这些点都是我们的 word，或是我们的 sentence，或是我们的 document。OK，那今天我们想要分群，在我不知道这些 word 它应该要怎么分辨，我不知道这些 sentence 怎么分，它是属于哪一个类别，document 不知道是属于什么样的类别的时候，我们就可以用 clustering 的方式。那我们过去相关的经验就是，我会有很多的动词，然后我当然有它的 word embedding，然后再接下来我想要分群这些动词，它是属于什么样的类型的动作好了。但我没有这样的定义啊，那这样我们就可以用 clustering 来帮我们做这件事情。OK， so the next step, let's write out the k-means algorithm more formally. So the k-means algorithm takes 2 points. The one is parameter k. K represents the number of cluster, and remember that the number of cluster is defined by ourselves. So here is another question: how do we choose proper number of k? Um, but now we first from the case of deciding a certain number of cluster by ourselves, and um, and then k-means also take as input this sort of unlabeled training set of just the x, and because it is unsupervised learning, so we don't have the label of like y in this case. So for example, in natural language processing, X means the word vector or your sentence vector or document vector. Okay, and we can represent the data point X is um, uh, are n-dimensional vectors. So we already know that the first step of K-means algorithm is randomly initialize K cluster century, uh, uh, which we'll call mu1, mu2 to mu k, where k is the number of cluster, right? And for example, in the previous slide, the mu1 can be the red cluster and mu2 can be the blue cluster centroid. And so there we had two cluster centroid, for example. So um, um, uh, so in this case, k is 2. Okay, so let's go on to see the following process. Uh, so the inner loop of k means in the following, uh, we are going to repeatedly to do the following process, and you can see the first step uh, in this loop of k-means is called cluster assignment step. Okay, so first of each of our training uh, example, the variable ci is set to be the index 1 through to k of the cluster century closest to the training data xi. And this was a cluster assignment step where we took each of our uh, data point and color it either red or blue, depending on the distance. Okay, so CI is going to be number 1 to K, means that uh, uh, it is closer to the mu1 cluster century or close close to the mu2 cluster century. And another way to write this is to compute CI. So we are going to measure the distance of each of uh, the between the uh, data point and the cluster centroid. So the here you can see that uh, we I write the lower k means the uh, index of different cluster century, and the uppercase k means the total number of cluster. Okay, so uh, here is the way to related to the process of this this comment. Okay, and uh, so we want to choose uh, the cluster of the data point is to minimize the distance between the xi and the cluster century. Okay, and another way to write this equation is to if I write the norm between xi and mu k, and this is the distance between the I example and cluster century mu k. So uh, uh, that means the distance between the example and the cluster century, we do this to find the value of k, or so that it can minimize these equations. So uh, um, we say that we write the distance between the xi and the cluster centroid. So we think of Ci is picking the cluster centroid with the smallest square distance of our training sample xi. So that these that are uh, cluster assignment step. And the other uh, loop of k-means is the move centroid step. And what um, what does cent oh sorry, here is a typo. uh, uh, Move centroid. So for in this case, in this step, um, the lowercase k uh, equals 1 through k, uppercase k. So it's set mu k equal to the average of the points assigned to cluster. So as taking this as an example, let's say one of our cluster centroid uh, um, is 2. Okay, so if we have the training example like x1, x5, x6, x10 uh, belong to the uh, second cluster, then we can write c1 equal to 2 and c5 equal to 2 and c6 belong to equal to 2 and so on. Then we have to compute the means of these data points. So uh, we can sum up these data points and compute the average of these data points to get back the new relation of the mu2. So mu2 is going to be an n-dimensional vector that uh, is the mean of these 4 data points. So we add up these things and divide by 4 because we have 4 data points. So we end up with the move centroid step, and uh, then we get the new cluster centroid location of mu k. Sorry, mu2. Okay. So you may think that if uh, we cannot find uh, the 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 point assigned to some cluster, so how can we solve this problem? So in this case, that a more common way to do is to eliminate the cluster centroid. So if we really we can find the one of cluster that no point can be assigned to it. So just remove the least cluster centroid. And but actually in most case um, there are this question sorry, this problem is rarely happened. So uh, uh, this is the algorithm of k-means. 所以就是简单来说，就是这边是只是把前面的步骤写的比较像 formal 一点，就是当然我们先去找距离比较近的，那找距离比较近的就是这样的写法，就是知道说每个点是属于哪个 cluster centroid，然后接下来就是去找出属于那个 cluster centroid 的那些点，然后计算它平均去 assign 它新的这个 location。And next, let's talk about how to initialize k-means. So here is the k-means clustering algorithm. Start from randomly initialize k cluster centroid. So the question is how to readily initialize the cluster centroid. Um, there are a few different ways that one can imagine using to randomly initialize the cluster centroid. Um, but uh, there are there is one method that is much more recommended is um, uh, 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 there are some method, but one of method would be much more recommended. So in the following slide, we will discuss that options. Okay. So uh, for the random initialization step, uh, first we have to define the number of clusters. So um, when running k-means, we have a number of cluster centroid k that uh, must be less than the number of training example m. So k is the number of cluster must be lower than m example. So uh, the way to initialize k-mean is randomly pick k training example. So and then it sets the set mu1 to mu k equal to these k example. And so for example, you may choose the 2 points, then you can find out that these data points is closer to this random initialized cluster centroid. So uh, then uh, you can say this is a better case, but if we choose um, these 2 points, then um, uh, you can say that this is not lucky to choose the better point. And so in this case, you would be hard to assign the cluster centroid. So uh, so it's actually use different uh, um, method to initialize our cluster centroid. So um, you can uh, guess that k-means can end up covering to different solution depending on exactly how the cluster were initialized, depending on the random initialize. And k-means can end up at different solution. So this is related to the problem of local minima. If we are given the data like this, then um, if we run k-means, and if uh, we start from a great start, uh, and it end up a good local optima, that might be really good for the global optima. So we end up with uh, the three cluster, and you can see that this is a better result that um, you may find um, uh, like these data points really close to this uh, cluster centroid, and there are a large distance between different clusters. And k-means can also get stuck at different local optima, like in this example, it look like the blue cluster has captured a lot of points, and the green cluster is relatively small, uh, smaller than these two clusters. So it is corresponds to a bad local optima because it has basically taken these two clusters and used them into uh, uh, um, we have to separate these data points that are close each other into two clusters. So in this case, uh, it is another local optima of k-means, and so you can see that the green cluster capture a relatively largest number of uh, data points, and you can see that only one data point uh, belongs to the red cross. So if we worry about k-means stuck in local optima, if we want to increase uh, the odds of k-means finding the best possible k-means, uh, we what we can do is to try multiple random initialization. So initialize k means lots of time and run k means lots of time and use that to try to make sure we get as good a solution and a good local or global optima as possible. 这边只是说，如果我们就是这就可能会选到不好的开始嘛，然后我们就会得到不好的结果。那就是说，就是多尝试几次，然后根据结果来衡量。那我们就可以找到相对比较好的的解，而不会卡在local optima。好。那刚好时间到要下课时间了，那后面的内容基本上就是说跟我们cluster 这个vector 啊，还有后面会介绍到我们怎么用PCA 来帮助我们分析我们的 word embedding。好，那我们今天就先上课到这边，好，大家可以下课休息了。